Good morning to all. Welcome back to our course on the C programming language. In this session, I am going to discuss about the same concept, that is the arrays in C, and this is part 3 of arrays. Initially, we have discussed the introduction to arrays, and then we have gone through the properties of arrays along with the declaration of arrays, and finally we have discussed the memory representation in the previous sessions. In today's session, we are going to discuss about one of the important topic related to arrays, that is the initialization of arrays. Initialization is a process where we are going to assign some values at the time of declaration itself, or you are going to give some initial values. Basically, we know that the default storage class of any variable will be auto, and the default value for the automatic variables is garbage. For example, if the programmer does not want to have the garbage values initially, in that situation the programmer has to give some initial values so that these initial values will be replacing the garbage values. For this purpose, we require some initial values to be assigned to variables, and the concept of initialization has been extended to arrays also. We know that arrays are nothing but the collection of elements of similar data type, and they occupy the contiguous memory locations. So if you have some n number of elements in an array, all the elements can be initialized by some default values by making use of the concept of initialization of arrays. In today's session, we will be discussing about the initialization of arrays, that is one-dimensional arrays. Till now, we have seen the types of arrays in the introductory concepts to arrays. We have seen that there are two major classification or major types of arrays, that is one-dimensional and multi-dimensional arrays. Whatever we have discussed till now is related to one-dimensional arrays. Here also in today's session we are going to discuss about the initialization of arrays, the two one-dimensional arrays. In short form, we can simply write it as 1D array. D stands for dimension of the array. Basically, the initialization of arrays can be done in two ways. The first method is initializing the individual elements. Initializing the individual elements of the array. This is the first method. And the second method is initialization at the time of declaration itself. Both of them are important, and a programmer or an user can make use of any type of this initialization based upon his or her requirement. Either the programmer can go with the initialization of individual elements, or he can go with the initialization part at the time of declaration itself. So we will discuss about these two initializations in today's class with few examples. Let us go with the first part, that is how we are going to initialize the elements of the arrays individually. Initialization of individual elements. So I will write a simple program to discuss this concept. The first part is we are going to include the preprocessor directives #include stdio.h, and I am going to start my main program. After this, I have to initialize, I have to first declare an array. Before initialization, you have to declare an array. So I declare an integer array let me take the name of the array as A, and let me take the size of this A as 5. So this is how I declare the integer array. So this is called as declaration. We know that the memory allocation happens for all the variables at the time of declaration only. So when the compiler comes across this statement, it will come to know that the user or the programmer is trying to allocate 5 integer elements in the form of an array, and the name of the array is A. So if you look at the memory representation, I'm just drawing here this one. Since you are going to store 5 elements, 5 blocks, contiguous blocks of elements will be, memory will be allocated. The index number, as we know that it always starts with 0 and ends with n minus 1, where n is the size of the array. Here the n value is 5, therefore the largest index will be 4. And remember that each and every cell represents 4 bytes of memory. Why? Because we have declared an array of integer type. So this array A is capable of storing 5 integer elements, where each and every integer takes 4 bytes. Therefore the total memory that is occupied will be 20 bytes. This formula we have given in the previous discussion while we are discussing the concept of declaration of C as well as the memory representations. When this memory allocation happened, what happens here is this is taken, the array is taken as automatic variables. By default, the default storage class of any variable will be auto. We know this very well. And the default value of these automatic variables will be garbage value. So all the 5 elements of A will be taken as garbage. Therefore some default or garbage values will be there like this. We cannot expect what is there in it. That's the reason why we call them as the garbage values. Once this is done, my intention is to initialize the values individual elements. That means I can initialize this value individually. I can take this value as A of 0. Similarly, I can take this value as A of 1, and I can take this value as A of 2. This will be A of 3, and this will be A of 4. We know this very well, right? And my intention is to initialize these elements individually. So I can take this value. For example, if I want to initialize the first element, so I have to take it as A of 0. I want to initialize it to 10. You have to use an assignment operator is equal to, and the value you have to give. So 10 will be assigned to A of 0. So what happens here is, instead of garbage value, 10 will be taken. Similarly, if I want to give the first element or second element, I can access the second element with this index number, that is 1. A of 1 is the second element. We are locating this one. This location is given as A of 1. And if I want to assign a value of 20, I just use the assignment operator and the value is assigned. We know that assignment operator is right to left associative. So it will assign the value that is present on the right hand side to the left hand side. So instead of garbage value, here I will have 20. Like that you can initialize all the values. Let me take the third value, that is A of 2 is initialized to 30, and let me take A of 3 is initialized to 40, and the last element, that is fifth element, that is A of 4 is initialized to 50. So what happens here is, when we, after this program is compiled, it will simply replace these garbage values with the values that are assigned like this. This is a very simple program which illustrates how we can initialize the individual elements of the array with the values that we want. I'm not concentrating on how we can print the values and how we can access the values. All these things we'll be discussing in part 4, the next session. So this is the first way of initializing the individual elements of the array. Now let us go with the second method, where I can initialize the entire array with at the time of declaration itself, right? So the second method is how we are going to initialize at the time of declaration. So let me explain this again with a simple program, very simple program, as we have done in the previous one. Let me include my stdio.h to make use of the standard input and output functions, and my main function int main. Listen, this is very important. So this particular part is initializing the array with at the time of declaration itself, right? So at the time of declaration, I know how to declare an array. Int a of 5, let me take it. This is declaration, and I want to initialize it at the same statement. So I make use of again the assignment operator, and I know that this a can hold 5 different integer values. So what you can do here is you have to initialize this a with 5 integer values. So you have to give a list of values, list of 5 integer values. When we initialize list of values means we know that they should be separated with commas, right? So let me take the values as 10, 20, 30, 40 and 50. And all these list of values that are separated by commas should be enclosed within these curly braces, and you have to use the statement terminator semicolon like this. Very simple thing. So what happens when the compiler comes across this statement is we know that it will allocate 5 different 5 contiguous memory locations like this, and we know that the index numbers will be from 0 to 4, and this declaration is followed by the initialization. Therefore it won't store the garbage values. So the first value what it is given here, that is 10, will be stored as the first element. So the first element we know that it is a of 0. So in a of 0, 10 will be stored, and the second element 20 is stored in first location, that is first index, and the third element 30 is stored in the second index, 40 is stored in the third index, and 50 is stored in the last index, that is 4. So this is how, very simple thing, right? This is how we are going to initialize the arrays at the time of declaration. Everything remains same, but the initialization is done at the time of declaration itself. Here you should be very careful. Few important points that I would like to stress here is, when you are initializing the arrays at the time of declaration, then you should be very careful in the initialization part what care you should take. That is what I am going to discuss, right? See here, I am assigning or I am giving the initial values to this a of 5, that means 5 elements. You can give 5 elements, and remember that you cannot initialize the array randomly. That means, very important point, note, no random initialization is possible in this case. no random initialization. That means, for example, if the programmer wants to initialize the first element, third element and fifth element, so you cannot initialize like this 10 space 20 space 10 30, right, 10 30 space 50. These type of initializations are completely avoided, or they are not accepted. So this we can call it as the name at the time of declaration. While you are initializing, we can call this list of elements as initializer list. This is just a terminology. Maybe this is not a thumb rule. We can make use of it as the initializer list. Nothing wrong in it. Right. So the first note what we have discussed is no random initialization is allowed in this type of initializer list. So when you want to initialize an array with the initializer list, you should give the initialization list in a sequence. That means the first element is always stored with the first location, the second element is always stored with the second location, the third element is stored at the third location. So you cannot initialize randomly. You cannot initialize 0th, 2nd and 4th index values, leaving it behind this 1 and 3. And second important point, while you are initializing the array with the initializer list, you can give the less elements. For example, I have a of 5. I need to give 5 initial values, but I have given only 3 values like this. Let me take it, int a of 5. This is another example. Int a of 5 is equal 10, 20, 30. This is the initializer list which consists of only 3 values, but I need to initialize it with 5 values. Is it a correct way of initializing? Yes, it is correct. Definitely it is correct. Why? Because in what happens in this situation, let me explain it. While this declaration statement, I know that 5 elements or 5 memory locations will be allocated and the index numbers starts with 0 to 4, and I have initialized it to 3 values, so 10, 20 and 30. So the 10 will automatically occupy the 0th index, 20 will occupy the second index, 30 will occupy the third index. But what happens to the remaining elements? So what happens to these remaining elements means they will be automatically assigned a value of 0 by the compilers. Very important thing. So when the initializer list is having less values than the size of the array, then the remaining elements will be automatically assigned a value of 0. So you can see here that 10, 20, 30 has occupied these 3 locations, and the last 2 locations, that is index 3 and index 4, is occupying a value of 0. This is very important point. And one more thing we can understand here, the third important note is, you may get a doubt that what happens if I initialize the array with more values. Is it possible? Yes, it is possible, right? But it will give an error. It will give an error. So for example, I have declared an array of a with 5 and I have assigned it with these 6 values, 60, right? This will give an error. Why? Because you have allocated memory for only 5 elements, but you are trying to initialize it with 6 values. Therefore, this will be an error. These are the 3 important points you should understand while you are making use of this initializer list. The first one is, No random initialization is possible. Whenever you want to initialize, you have to start initializing it with the first element, and you can end it at any value that is less than the size of the array. And the second one is initialization list may consist of less number of values than the size of the array. This is perfect. So what happens here is, we discussed that the remaining element, the uninitialized elements, will be initialized to 0 automatically by the compiler. And the third case what we have discussed is, what happens if you have the initializer list consisting of more number of values than the actual size of the array. In that case you will get an error. So this is all about the initialization of arrays. Let me go through the discussions once again, a quick recap of what we have discussed in today's session. In this session we have started our discussion with the initialization of arrays, that too one-dimensional array. We can do the initialization of arrays in two ways. The first one is, you can initialize the individual elements with some values. This example we have given, where I have initialized the individual values. And the second one is initialization of array at the time of declaration. We call it as using the initializer list. One programming examples also we have discussed, and how the elements are stored, that also we have discussed. And we have discussed three important notes regarding the initializer list. No random initialization, less number of values in the initializer list when compared to that of the size of the array, more number of initializer values in the initializer list when compared to that of the size of the array. Everything we have discussed. So that's all for today's discussion. Thank you one and all for joining the session.